Hey y'all, welcome to your Algebra 2 lesson 4.4. We're going to solve ax squared plus bx plus c equals 0 by factoring. That's our goal. Okay, so our objective today is you will use factoring and the zero product property to solve equations of the form ax squared plus bx plus c equals 0. Now, last time you learned how to solve equations of the form x squared plus bx plus c equals 0. Now we're going to look at more interesting values for a other than 1. To solve equations in the form ax squared plus bx plus c equals 0, we must first factor ax squared plus bx plus c. Although this factorization can be accomplished in a similar fashion to what we learned last class, this is most easily accomplished by using what we call the AC method. It's really the absolute value of AC method, but everybody just calls it the AC method. For each trinomial ax squared plus bx plus c, we're going to identify a, b, and c. We're going to list all factors of the absolute value of AC, starting with 1 absolute value of AC, and continuing until you start getting repeats, and I'll show you how to do that. Then you're going to consider combinations until you get the correct value of B. And by combinations, that means add or subtract. You're going to add if C is positive, and you're going to subtract if C is negative. Okay, so let's see this in action. We're going to factor 5x squared minus 17x plus 6. All right, so first thing we do is we identify a, b, and c. So a is 5, b is negative 17, c is 6. And then we figure out AC, the absolute value of AC. So the absolute value of 5 times 6 is absolute value of 30, which is 30. So the first factor pair is 1 and 30. And then you think about 2. Well, does 2 work? Sure. 2 and 15. What about 3? Yep, 3 and 10. 4, nope, it doesn't multiply with another integer to give us 30. 5, yes, 5 and 6. 6, yes, 6 and 5. Oh, wait, that's a repeat. We already have 5 and 6. 6 and 5 is just the same thing, just in a different order. So we get to cross that one out and we know we're done. So if you start with 1 and go up, count up by ones, once you hit a repeat, you know you've considered all possible combinations. All right, so now we look at C and go, C is 6, so that's positive, so we add. If C is positive, we add. If it's negative, we subtract. So we're going to look at the sum of our factor pairs. 1 plus 30 is 31. That's not equal to 17. 2 plus 15 is equal to 17, but we want negative 17. And so we will use negative 2 and negative 15. So what we're going to do now is we're going to rewrite 5x squared minus 17x plus 6 using negative 2 and negative 15. We're going to replace negative 17x with negative 2x minus 15x. Or if you want to think of it as negative 2x plus negative 15x, that's fine. The way we're going to write that is 5x squared minus 2x minus 15x plus 6. So we haven't really factored anything yet. We've just figured out how to break up the negative 17x to give us what we need to be able to factor well. Okay, so the negative 17x is replaced by negative 2x minus 15x. Now we're going to factor this with factoring by grouping. And remember, that's where you take the terms in groups usually, and in this case 2 by 2. So I'm going to factor out a common factor out of the first two terms, out of the 5x squared minus 2x. Then I'm going to factor the greatest common factor out of the minus 15x plus 6. So that's called factoring by grouping. We're going to consider the first two a group and the second two a group and factor out greatest common factors. So looking at 5x squared minus 2x, the only common factor there is x. So I'm going to have x times 5x minus 2. And then out of minus 15x plus 6, I can factor out a 3. Because there's a minus sign there, though, I'm factoring out minus 3 or negative 3. So negative 15x divided by negative 3 is 5x. 6 divided by negative 3 is negative 2. Another thing you can look at is that if you distribute the negative 3, do you get back at what you started with? So negative 3 times 5x is negative 15x. Negative 3 times negative 2 is positive 6. So this works. Okay, so what this has done for us is we've gone from having 1, 2, 3, 4 terms to having one big term minus another big term. So you look and go, okay, I've got two terms now. Do they have a factor in common? Well, sure, they both have a 5x minus 2. The binomial there is a common factor. So we bring the 5x minus 2 out front, and whatever we have left, we put in parentheses. So we have x minus 3. Now, one thing you can always stop and do is FOIL and see if you end up back with what you started with, and that's a way to check. Okay, so 5x times x is 5x squared. Negative 2 times x is negative 2x. 5x times negative 3 is negative 15x. And then negative 2 times negative 3 is plus 6. So that gets us back to what we started with, so we know we did a good job. Okay, so that's our answer, and we know it's the answer because we have the original polynomial, 5x squared minus 17x plus 6, written as the product of two binomial factors. All right, now let's try it with 3x squared plus 20x minus 7. So A is 3, B is 20, C is negative 7. So absolute value of AC is the absolute value of 3 times negative 7. So absolute value of 21 is 21. Or absolute value of negative 21 is 21. All right, so we want factors of 21. So obviously 1 and 21. And then we ask ourselves, okay, does 2 work? No. What about 3? Yep, 3 and 7. 4? Nope. 5? Nope. 6? Nope. 7? Yes, it's 7 and 3, but that's a repeat. So we know we're done. All right, C is negative, so we're looking for subtracting to get 20. So let's see, we've got 1 minus 21 is negative 20. Well, we want positive 20, so we would use positive 21 and negative 20. Okay, positive 21 and negative 20 because we want, instead of negative 20, we want it to be positive 20. So we're going to write 3x squared plus 20x minus 7 as 3x squared minus 1x plus 21x minus 7. So what I'm going to do now is I'm going to do the factoring by grouping where I take the first two together and then the second two together, and I factor out the greatest common factor. So looking at 3x squared minus 1x, and remember I did the minus 1x and the plus 21x because I want it to come out to be plus 20x. I knew when I did 1 minus 21 I got negative 20. That's the opposite of what I want, so I just switch it out and do, okay, 21 minus 1, or negative 1 plus 21. Okay, so 3x squared minus 1x, I'm going to pull out an x. 21x minus 7, I'm going to factor out a 7. So I get x times 3x minus 1 plus 7 times 3x minus 1. And so they have 3x minus 1 in common in my two new terms here. My big old term x times 3x minus 1 and my big old term 7 times 3x minus 1. So I bring the 3x minus 1 out front, and then whatever it was multiplying I put in parentheses. So it was multiplying x, so x goes in the front of the parentheses, and then plus 7, that goes in the back of the parentheses. There's my 21 minus 1 equals 20. Right. So that's why we used the positive 21 and the minus 1x, because we wanted it to equal positive 20. All right, so our answer is 3x minus 1 times x plus 7. Again, we've gotten our original trinomial 3x squared plus 20x minus 7 written as a product of factors. In this case, a product of two binomial factors. Okay, let's look at one more example, and then we'll stop and we'll move on to video 2. We're going to revisit some of those special patterns. Remember last class we looked at some fairly simple examples of factoring by special patterns. Today we will look at some that are a little more involved. Okay, we're going to factor each expression. We've got 9x squared minus 64. Because of the x squared and the minus sign and the fact that there's two terms there, that's a big hint that this might be a difference of two squares. What you want to do is you want to look and see if you can write that whole first term as something squared. 9 is a perfect square, so you can write 9x squared as 3x, that whole quantity squared, because 3 squared is 9 and x squared is x squared. And then minus and 64 is 8 squared. So we have a difference of two squares. So we'll have 3x plus 8 and then 3x minus 8. And if you want to, you can FOIL that back out, and you'll end up with 9x squared minus 64. Let's look at 4y squared plus 20y plus 25. Okay, we've got y squared at the front. We've got 25, which is 5 squared at the end. 4 looks like it's a square. It's 2 squared, so maybe this will work. Let's see. Let's see if it fits the pattern. 4y squared can be written as 2y, the whole thing squared, plus, let's see, 20y. Can we write that as 2 times that 2y plus times 5? We sure can, because 2 times 2y is 4y, times 5 is 20y. And that works out because the 25 is written as 5 squared. So we've got our first base squared plus 2 times the first base times the second base plus second base squared. That means that this can be factored using the perfect square trinomial pattern. So it's going to be 2y plus 5 squared. How do we know that it's plus 5? Because we've got a plus in front of our linear term, in front of our 20y term. If it was a minus there, we'd have a minus inside our parentheses, but we have a plus. Speaking of minuses inside the parentheses and minuses in front of the linear term, we've got 36w squared minus 12w plus 1. Well, 1's a perfect squared. If squared, it just equals 1 squared. And 36 is 6 squared, so this might be a perfect square trinomial. Let's just make sure that middle term fits the pattern of 2 times first base times second base. Well, the first base is going to be 6w, the whole thing squared, because 6 squared is 36, w squared is w squared. And then we've got our minus, and then 2, our first base is 6w, times our second base is 1. So let's just double check. 2 times 6 is 12. Times 1 is 12w, so that works because our second base there is 1. 1 is kind of nice because 1 squared equals 1, 1 cubed equals 1, 1 equals any power of itself. So this is a perfect square trinomial because we do have a minus there in the linear term. It's going to be 6w minus 1 squared. Okay, that's it for video number 1. We're going to come back and talk about some greatest common factors and how those come into play in video 2. I'll see you in a few minutes.